Okay, welcome to another video for A-level math. Today's objective is to do some challenge questions since the P1 exam is coming up. Some of you requested that I should do some difficult questions or point out some difficult questions. So feel free to pause the video, solve the question yourself, and then match it with my answer as you go on. I am starting backwards from February 2023, and what I've done is I've filtered some questions out that I feel are more challenging, and we'll solve them. So this first question is from February 2023. It says a line has equation 3x minus 2k and a curve has equation x squared minus kx plus 2. A k is a constant. Show that the line and the curve meet. When it says meet, it's simply b square minus 4ac should be greater than or equals to 0. But you notice that I'm asking you to show for all values of k. I'm not asking you to find the values of k. I'm asking you to show for all values of k. So in that case, you start off with the same process. You start off with thinking about b square minus 4ac, and you sort of equate these two equations that you have. One is for the curve and the other is for the line. Let's see what happens. So I bring everything to one side, minus kx minus 3x plus 2 plus 2k. So a is 1, b is minus k minus 3, and c is 2 plus 2k. Okay, then what I'm going to do is I'm going to just put it into b square minus 4ac. Now I'm not putting an inequality. Why? Because I have to show for all values of x. That's the trick in this question. So when you expand this, if you're confused about whether it's going to be a positive or a negative, the idea is that this opens up to become a plus b whole square. Or you can also write it like that. In order to avoid all confusions, you can write it like that and then expand. What I'm going to do is I'm going to just write k square plus 6k plus 9, because I know that's what's going to turn up. So I get k square minus 2k plus 1. Now, how do you prove that something is a whole square? The idea is very simple, that something is always greater than or equals to 0. The idea is very simple, that you try to bring in a square, a whole square into the equation. So what I'm talking about is completing the square. But this equation is pretty obvious. If you notice, I can break the middle term, and you see what I get is, let's say I break the middle term into minus k plus 1, and I factorize it. That is what I get. I get k minus 1 into k minus 1, and that's k minus 1 whole square. So I can say that this expression is greater than equals to 0 for all values of k. Therefore, line and curve always meet. I don't know if it's one meeting point or two meeting point. That is what I don't know, but that is what this question is about. That's about concluding whether the line and curve meet or not, and for all values of k, regardless of whatever value of k you put in, that's the answer that you get. That's the first challenging question. 3. Then I've cancelled this, then I've kept this. There's a reason I've kept this question. Let's try to solve this. This says the circumference around the trunk of a large tree is measured and found to be 5.00 meters. After 1 year, the circumference is measured again and found to be 5.02 meters. Given that the circumference at yearly intervals form an arithmetic progression, find the circumference 20 years after the first measurement. So they are in arithmetic progression, so I'm going to say that term 1 or a is 5.00. That's when it was first measured after 1 year, so that's term 2. So yeah, that's year 1. After year 1, at the end of year 1, 5.02. So I find out that d is basically 0.02 and a is 5.00. It says find the circumference 20 years after the first measurement. So that was 1 year after the first measurement. So I'm basically asking you to find out at the end of year 20. So remember that the term is going to be term number 21. That is what I want to point out. Because if you added 19 here, you add 19 here as well. You add 19 years to get to year 20. So therefore you add 19 years to term 2 to get term 21. If you've kept the first term as 5.00. If you calculate the 20th term, that's going to be wrong. So what I'm going to do is the term formula is a plus n minus 1d. So I'm going to write that it's term number 21. So that's 5 plus 21 minus 1 times 0.02. Because it's year 20, not term 20. That gives me 5.4 meters. Okay. Then this is given instead the circumference at yearly intervals from a geometric progression. So 5. Term 2 or year 1 is 5.02. So in that case I can calculate R, 5.02 divided by 5.00. Let's see what that gives me. That's 1.004. Okay, and then it says find the circumference 20 years after. So again, I'm asking you for year 20, which means I'm asking you for term number 21. So A or power n minus 1. That's rounded to 3 significant figures, 5.14557. So 5.42 is my final answer. So that's that. Then this was relatively easy, so I've skipped that. I've kept this one because this looked a little confusing, although it's not a very challenging question. It says in the expansion of x over a plus a over x square, it is given that the coefficient of x power 4 divided by the coefficient of x equals to 3. So coefficient of x power 4. So I'm going to first write my formula 7c or x over a power 7 minus r and a over x square power r. That's how I solve binomial questions. So now what power do I need? The expression that I have is 7 minus r x power 2r in the denominator, and I want it to be equal to x power 4 first. So I'm going to say 7 minus 4 x power 2 into 7 minus r minus 2r equals to x power 4. So 7 minus 3r should equal 4 and r should equal 1. So the term in x power 4 is 7c1, x over a power 7 minus 1, a over x square power 1. So I get 7c1, x power 6 and x power 2 in the denominator, so x power 4 and a over a power 6, so that's 7, denominator has a power 5 and x power 4. That's the first x power 4 term. Then I'm also looking for the coefficient of x. So I'm going to say that I'm again going to do the same process, this time with x power 1. So I'm getting r as 2. So I'm going to again write 7c2 x over a 7 minus 2 a over x square power 2. So I get 7c2 is basically 7 into 6 is 42 divided by 2 is 21, I think. 7c2, yeah, 21. X power 1 because x power 5 divided by x power 4, and I have a square divided by a power 5, so that's 21 a cubed in the denominator and x. Now what else do I know? I know that when these coefficients are divided, I get equals to I get 3. So I'm going to say that 7x power 4 divided by a power 5 over okay, I'm just looking at the coefficients, so let's just write coefficients. Seven divided by a power 5 and 21 divided by a cubed. and that should equal 3. So I get 1 over a squared equals to 9. A squared is therefore equals to 1 over 9. And let me see if it's positive. Find the possible values. So a is both positive 1/3 and negative 1/3. Okay, moving on. All these are relatively easy questions, so I'll just cancel them out. Let's look at this one. This is a question on functions. Not very challenging. It's just the last part. I think that's the reason that I've kept it here. The function is defined by this. I can see that the turning point is, if I can write it like that, x minus 0 whole square plus 2. I can see that 0 comma 2 is a turning point, and it's a sad face curve. It says find the range of f. So I can draw a small sketch. I can say that this point is 0 comma 2, but this curve is not starting from 0, it's starting from minus 1. So it's starting somewhere from here. So I'm going to have to find where minus 1 is. That gives me minus 1. So this is minus 1 comma minus 1. And the curve is going to the left. So I can erase the right hand side of the curve and say that the range of this is y is less than or equals to minus 1 as well. If the domain is less than equals to minus 1, the range is also that. Then for the inverse, so I've made x squared as object. When I take a root on both sides, it generates both a plus and a minus. Now since this curve is to the left of the turning point, there is going to be a negative outside the root. If you don't know this, please go back and watch the lecture videos. That's where I explain why this is the case. So this becomes f inverse of x equals to minus root of x minus 2 over minus 3. So that's another question. Then it says the function g is defined by this. So that's another function, and then that's again less than or equals to minus 1. It says solve the equation fg of x minus gf of x plus 8, and that's a huge 5-mark question. So let's just first write down our number is minus 3x squared plus 2. Okay, so fg of x would be minus 3 minus x squared minus 1 plus 2, and gf of x would be minus 3x squared plus 2 squared minus 1 plus 8 equals to 0. And this should also be squared. So let's try to expand this then. This becomes x power 4 2x squared plus 1, as I just told you in the previous question. Let's first expand this. 9x power 4 12x squared plus 4 minus 1 plus 8 equals to 0. So minus 3x power 4 minus 6x squared minus 3 plus 2. You get a plus, and then 2 negatives make a plus, and then that becomes plus 9x power 4 plus 12x squared plus 4 plus 1 plus 8 equals to 0. I hope I have not made a silly mistake somewhere. 6x power 4 12x squared is minus 6x squared is plus 6x squared. Then I have minus 1 here, I have plus 1 here, so that gives me plus 12 equals to 0. So x power 4 x squared plus 2 equals to 0. I have a feeling there's a small error somewhere. Let me just verify this from the marking scheme before we make a mistake. I'll just open up and see if I've made a mistake. Okay, so there is a small error, and that error is basically in this sign that I've not really looked at properly. So this is a minus, that is a minus 18x squared. So that gives me minus 3x squared. So if I factorize this, this simply becomes minus 2x squared and minus x squared. That gives me a plus 2. So I can just do that, or I can use this guy's equations, whatever you feel comfortable with. And I get x squared minus 2, x squared minus 1 equals to 0. So x squared equals to 2 and x squared equals to 1. X is therefore equals to plus minus root of 2. X is therefore equals to plus minus root of 1, which is minus or 2, 1. So I get 4 answers, and that should be it. Let me just verify if those 4 answers are the answers that we are looking for. But I just have negative answers, and the simple reason is that these domains were both negative. Therefore, the only answers are minus root 2 and minus 1. That was my initial feeling. But since I made a mistake, that was something that I missed. So if you miss that, 1 mark gets deducted. So make sure that you remember to check whether it lies in the domain or not. Moving on. There is another question that seems a little challenging. Let's try to do this. Although it's not very challenging, but I'm still going to do it. I'm still doing February 2023, February, March 2023. So let's quickly do that. It says find an equation of the line AB. So I'm going to first find the gradient, y2 minus y1 over x2 minus x1. That's 1. So that line is that y minus y1 mx minus x1. So I get y equals to x minus 3. That's the equation of that line. That's relatively simple. Then it says find the volume of the revolution when the shaded region between the curve and the line AB is rotated 360 degrees about the y-axis. So remember that I'm rotating like that, so I'll need the limits for y, and I can see that the limits are basically 2 and minus 1. So I'm going to first write that minus 1 and 2, put a pi outside. Now I always do this. Now I have to look at the y-axis. So that's above for me, and that's below, because that's the below one will give me the lower volume. So how I do this question is simply above squared minus below squared. Now both, and dy in this case. Why? Because I'm rotating on the y-axis. So I know I need both equations in terms of y. So the one above is basically, then again I say that this equation is y plus 3 equals to x. So I'm just going to write that the one above is y plus 3 whole squared. And the one below is the curve, the equation of the curve that's already given here, and x is already the subject. So I'm just going to say that it's y squared plus 1 whole square. Now integrating these, I'll bring in the limits back again. The first integration is simple, but when I'm integrating this, remember that I cannot integrate this directly. I have to first open this up because there's a quadratic inside. So y power 4 2y squared plus 1, and then I have to integrate this. So this becomes minus y power 5 over 5 plus 2y cubed over 3 plus y, and then I have to apply the limits on all of it. So I have the okay, so I'm going to write this as y plus 3 power 3 over 3 minus y power 5 over 5 minus 2y cube over 3 minus y, and then I'm going to use the limits minus 1 to 2. Let's see what I get. I'll write 2 plus 3 power 3 over 3 minus 2 power 5 over 5 minus 2 times 2 power 3 over 3 minus 2 negative the lower limit minus 1 plus 3 power 3 over 3. So I can just write just calculate so that this minus doesn't bother me. I get 2 power 3 over 3, and then minus 1 power 5 over 5 minus 2 minus 1 cubed over 3, and minus minus 1. Okay, so that's the mistake that I was doing earlier, which is why I wasn't getting the correct answer. So 5 cubed, so 125 over 3 minus 32 power 5, 32 over 5 minus 16 over 3 minus 2. So 419 over 15. Then 8 over 3, and that gives me plus 1 over 5 plus 2 over 3, I think, and then plus 1 as well. That gives me 68 over 15. So 419 over 15 minus answer, that's 23.4, and I have a pi at the end, so it's best to write it as a fraction and not as a decimal, because that's the wrong way of writing a number. 117 over 5 pi. Okay, moving on. That's the next exam that I have, November 2213. Let's try to do that. Let's see what questions I've marked. The first one is cancelled. Let's do this one. I think most of this question is fine. I don't think we need to do this one either. It's going to give me the same answers. I don't really want to go through that. In fact, there is one thing in that question that I sort of marked. Okay, let's quickly do this. It says minus 2. This is, remember, this is November 2213. Okay, I do the completing the square by comparison, so that's what I'm going to do. So I'm going to expand this. Okay, so minus 2 is equals to minus 2. That's fine. So 4 minus 8 should equal minus 4a. So a should equal 2. And minus 13 should equal minus 2a squared plus b. So b is 5. So I get minus 2x plus 2 whole square plus 5. No, that's minus 5, sorry, minus 5. Find the range of f. So remember that the range has to do something with the domain. So always sketch. Again, this is a sad face curve with the turning point minus 2 comma minus 5. But I see that the graph is basically not starting from minus 2, it's starting from minus 3. So let's see where it is at minus 3. So it's it should not be here. Let's plug in minus 3 first. Let's see what we get. So that's minus 7. So we are here. So we're going downwards from here. So I'm going to say that y is less than or equals to, y is less than minus 7, not even equals to, because that part of the domain was not included. So y is less than minus 7. Then again, for an expression for f inverse of x, so you start with the completed square form, and then you try to make x the subject. If when you put a root, remember that you have to consider both positives and negatives. Again, this is going to be a negative. Why? Because I'm taking the left hand side of the curve. So that becomes minus 2 minus x plus, let's just write y, plus 5 divided by minus 2, and that gives me f inverse of x. Okay, so this looks like an interesting question. So let's try to do this. There was a circle that was stretched, and it's a combination of two transformations. The first transformation is the translation of 7 comma minus 3. The second transformation applied is the stretch in the y direction. State the scale factor of the stretch. So what looks to me is that if it's not changed horizontally, so this should be the center of this new circle had it not been stretched. And to me this looks like the radius, which is basically 2 units. This it's important to look at the axis. I see the radius of the original circle is 2, so I'm just going to write that. Now I see that this radius is now this distance is basically 6 units. If the original radius was 2 and this is now 6, that means the scale factor was 3. That's how much it's stretched. But what I also want to point out is that it's this center would originally have been at a different position. Let's see what this says. State the coordinates of the center of the circle after the translation has been completed but before the stretch is applied. So what has actually happened is that every point got stretched. So if this point got stretched by a factor of 3, so this was originally should have been at 8,4. If this was at 8,4, the circle should have looked like this. And if the circle should have looked like this, the original center should have been here. It should have been at 8,2. That is after the translation and before the stretch. Now state the coordinates of the center of the original circle. So what I simply do is I take the translation and reverse it. So I have to move 7 in the positive direction, so I'm going to move 7 in the negative direction. I'm going to say 8 minus 7 is basically 1, and I have to go down by 3 units, so instead I'm going to go up by 3 units, and I'm going to say that 2 plus 3 is 5. So more sort of analytical question in terms of transformations. I've never seen a question like that before. Then we have another question. It says that cos alpha is this. Find without using the trigonometric functions on your calculator, which means that you can't calculate the angle right now, and you cannot give me an answer directly without using some method, because the examiner is now looking for a method. Calculating on your calculator is not a method. So what I'm going to do is I'm going to write cos alpha is equals to 8 over 17. Now we've all done this, so I'm going to say that if cos theta is 8 over 17, so that becomes 8 over 17 squared. I'm going to move it to the other side. And then take a root. I'm going to say that this is 8 over 17 both squared. That gives me 225 over 289 under the root, so that gives me 15 over 17. Okay, so sine alpha, or sine alpha, not theta, sine alpha, all these are alphas. So sine alpha is 15 over 17. Then what should be tan alpha? Tan alpha should simply be sine alpha over cos alpha, and that should give me 15 over 17 divided by 8 over 17, that's 15 over 8. Then what's 1 over sine alpha? 1 over sine alpha is simply 17 over 15, and what's 1 over tan alpha? That's 8 over 15. So I'm going to say that that gives me 25 over 15, and that should be 3. Let's check if that's the right answer. Question 6. So I get I made an error somewhere. Oh, it was 15 and I sort of, oh my bad, 5 over 3. Just made a simple calculation error at the end. 5 over 3. I don't know what I did. So moving on, that's another question that I want to do. It says the diagram shows two identical circles intersecting at points A and B with centers at P and Q. The radius of each circle is R and the distance PQ is 5 over 3R. So that's interesting. That's entire distance there for you. Okay. Find the perimeter of the shaded region in terms of R. So the perimeter is basically made up of two arc lengths, which should technically be equal because that's how this circle is working. So my objective basically is to somehow find this angle. Now how do I find this angle? That's R, and the entire thing is 5 over 3R. Can I say that this is going to drop at the center? So that should be 5 over 6r and 5 over 6r. So can I simply use my trigonometric ratios? Can I say that cos theta is 5 over 6r divided by r? So theta is cos inverse of 5 over 6 in radians. That's 0.586. So I can then say that the total angle is going to be 2 times 0.586. In fact, I should take a more accurate 5857 rather, 5857, so that we don't have a rounding off error. 2 into 0.5857. I get 1.1714. So the perimeter is then 2 times arc length. So that's 2 times r theta. I don't know why I'm making these errors right now. Find the area of the shaded region in terms of r. So can I say that I could split up the shaded region into 2 different parts, and then it's a simple question of 2 times area of segment. So area of shaded equals to 2 times area of segment. So area of sector minus area of triangle. So 2 times half r square theta. I'm taking the entire triangle. Half r into sine of 1.714. It's 1.1714. Point 4606 r squared. I've forgotten to multiply it with 1. Okay, I think I have gotten it correct now. 0.250 r squared. Okay, that's it for this question. Question 10. The diagram shows a circle this and the straight line y equals to 2x minus 1 intersecting at the points A and B. The point D on the x-axis such that AD is perpendicular to the x-axis. Okay. Find the coordinates of A. Okay, so I have the circle, I have the line. If I just want to find the coordinates of A, I can just solve them simultaneously. So I can replace y with 2x minus 1 whole squared equals to 2. So x squared plus 4x squared minus 4x plus 1 equals to 2. 5x squared minus 4x minus 1 equals to 0. I can basically factorize this, breaking the middle term. So 5x plus 1 and x minus 1 minus 1/5 and x is 1. This looks like 1. I'm going to say that's 1. and the y coordinate is then 2 times 1 minus 1, that's also 1. So A is basically 1 comma 1. Then it says find the volume of revolution when the shaded region A is rotated 360 degrees about the y-axis, giving your answer in the form pi over A b root c minus d, where a, b and c, a, b, c, d are integers. So I want to just rotate this. So I'm going to need the equation of this part of the curve. Now what we need to understand is that we're talking about the equation of a circle. So I have to first try to make y the subject, 2 minus x squared. Then I have to put a root. Now when I put a root, I have to decide whether it's a positive root or a negative root. So in this case, what is basically there is that if y is positive, then this equation should also be positive. If y is negative, then this equation should also have a negative outside. In this case, it's positive, so I'm going to take this equation. My intercepts were my limits would be 1, and this point will basically be the x-intercept of the equation. So I'm going to say that that's basically root 2. I'm going to integrate till root 2. So I'm going to first construct my formula. I'm going to say that pi y squared from 1 to root 2 pi, what's y squared? I'm going to write root of 2 minus x squared squared. So that gives me 2x minus x cubed over 3 after integration. The 1 to pi outside. Pi, so let's do this. 8 over 3 minus 2 minus 1/3. So that gives me, oh, that was root 2. Sorry, my bad. That's root 2. So 2 root 2 minus root 2 cubed over 3 minus 2 minus 1 over 3. Okay, so 2 root 2. If you know root 2 cubed is basically 2 root 2. There are 3 roots getting multiplied, so 2 of those roots combine together to give you a 2, and the other root remains, so that's 2 root 2 over 3 minus 2 plus 1 over 3. So I think my answer seems to be emerging. What I feel is I should take an altogether common denominator and say that this is 3, this is 6 root 2 minus 2 root 2 minus 6 plus 1. That comes outside. I get 4 root 2 minus 5 inside. I just want to verify if that those are the correct answers. I might have made a calculation mistake again, so I'm just checking. Yep, that's the correct answer. Find an exact expression for the perimeter of the shaded region. Okay, let's look at the perimeter. So one thing that I know is that this is the length that's there, so I can find that easily. How long is this question? 2 marks. Okay. Perimeter is the outer boundary. This length is basically the y coordinate, which is 1. So I have two lengths. Then if that's the sector, I will need to first find out what this angle is. Now this angle is simply, if this coordinate was 1 comma 1, then this angle is basically just 45 degrees or pi over 4, and that is obvious in the question with the coordinates that you're given. So I can just say that the perimeter is basically the vertical length plus the horizontal length plus r theta. R is root 2 into theta is pi over 4. So that gives me 1 plus root 2 minus 1 plus root 2 pi over 4. That gives me root 2 plus pi root 2 over 4. Let's check if that's the correct answer as well. Yep, that's the correct answer. stop here. Those were just two papers, but a lot of questions from there. I will be back with more challenging questions. So please make sure to press the bell icon so you get more updates. Thank you.